So it's question number 37 from the book Pathfinder, and it says like this. 37th question. A stick AB of length L stands vertically on a horizontal floor, leaning on a wall. So this is a stick. Initially, it is almost vertical initially, and then the end B is moved in forward direction so that the rod starts leaning. So a beetle P starts climbing the stick from the floor. So there's an insect that starts climbing on this rod. And when the beetle starts climbing, the lower end of the stick is made to move away from the wall with a constant velocity v. The beetle climbs the stick with a constant speed u relative to the stick. So beetle is moving with a speed u, while the lower end is dragged with a speed v. Both speeds are constant, and if the upper end A does not leave the wall, so this end continues to be in contact with the wall. What maximum height can the beetle rise? So this is the question. Suppose this is a situation after a time t, and the rod is making an angle theta with the horizontal, and in time t the beetle has moved by a distance u into t, and the height is, suppose h will be equal to, so that h will be equal to ut sine theta. You can verify. Check that this lower end of the rod has moved a distance vt in this time t, and therefore this height will be, using Pythagoras theorem, equal to under root L square minus V square T square. And now put the value of sine theta from this triangle. So this is the height after a time t, and we have to find the maximum height. That will occur when h, the differentiation of this h becomes 0, h dot. So h is the maximum when h dot is 0. Dot implies d by dt of h, that is 0. So just differentiate this expression. On doing that, you can verify it's done correctly. This is the differentiation, and put equal to 0 and solve for t. Uh, this you can verify, and I'm just solving for t. So t is equal to this expression. Vt comes out equal to L by root 2. So this is the time at which height will be maximum, and in this time Vt will be L by root 2. Vt is L by root 2 if you go back to the figure, and if Vt is L by root 2, it means theta is 45 degree at that instant. So, so when theta is 45 degree, so beetle will be at the maximum height. And what that height will be, just put the value of t and theta back into the expression of h. Just put the value of t. Sine theta will be 1 by root 2, theta being 45 degree. So this is the maximum height which this beetle will achieve. One thing is there, we are assuming that beetle is somewhere on the rod. That is, we are assuming that the distance covered by beetle, that is u into t, this is the value of t. So this is less than or equal to L. So that is, we are just assuming that beetle is somewhere on the rod, which further solves down to this expression. So we are assuming that u is less than or equal to v root 2. So if u happens to be less than or equal to v root 2, beetle will be on the rod somewhere, and its height will be given by the expression solved. Now, if you consider the other situation, that when u is more than v root 2 multiplied by t on both sides, I put the value of t also and solve, ut will be more than L. So this implies that the distance covered by beetle is more than the length of rod, and beetle has covered the whole length of rod. It means it will be somewhere on the wall then. So what is the maximum height of beetle while remaining on rod? In this case, the beetle will acquire the maximum height when it is at the upper end of the rod, whatever time it is. So we'll forget about this time, because at this time it has covered the whole length of rod, and somewhere it will be on wall. So now we'll consider the another time. So the time in which beetle reaches to the upper end. So that will be the maximum height condition for beetle in this situation. So that, what is that condition? That condition is when ut becomes equal to L and t becomes L by u from there. So at this time, beta will be at the upper end, and height will be at this time. To find height, this you can check that in this time the base will be Vt, which will be equal to, just put the value of t here, VL by u, and using Pythagoras theorem find h. Then h will come out equal to, using Pythagoras theorem, this expression, and h will be equal to this. So this will be the maximum height achieved by beetle in the condition when its speed is more than v root 2. Okay.